Welcome to the Explainer. Picture this. You're sitting in the exam hall. The clock is ticking. You turn the page of your Cambridge Mathematics past paper. Maybe it's a classic 0580 paper to start, or you're deep into the advanced syllabus, code 9709. Your heart sinks a little. The page is just a wall of complex numbers, modulus signs, and geometry. Most students see an impossible puzzle. But what if I told you that to top-performing candidates, there is no paper? There are only patterns. They literally see the code behind every single question. Today, we are going to decode that exam reality. The difference between a B and an A star in Cambridge Mathematics, particularly in Section 3.9 covering complex numbers and Loci and Argand diagrams, often comes down to this one crucial battleground. I'm going to show you exactly what senior examiners are looking for, because we see it all the time with two specific types of students. Let's call them Alex and Sam. Alex overloads the paper with raw mathematical facts, dumping every single formula onto the page with zero analysis. Sam, on the other hand, rushes. Sam completely misses the specific command word requirements and just draws a quick sketch. Both walk out of that exam hall thinking they absolutely crushed it. Both get their results and are devastated by the red pen marks. Let's change that reality for you right now.
So here is our Insider's Playbook for today. This is your mathematics success blueprint. First, we'll start by decoding the exam reality, looking at the actual code behind the marks. Then, we are going to move into the procedural framework, the exact step-by-step system you need. After that, we'll cover the top examiner warnings, so you can dodge the traps that catch out students like Alex and Sam. And finally, we'll wrap up with the critical analysis strategy to secure those top-tier marks. We're going to completely overhaul how you look at these questions.
All right, let's jump into Section 1, Decoding the Exam Reality. What does it actually mean to see the code behind the marks? Well, as the syllabus outlines, mastering Argand diagrams and loci isn't just about memorizing that the modulus of z minus a equals r is a circle. Any student can memorize a formula. It's about understanding why the argument of z creates a specific half-line, and more importantly, how the examiner asks you to prove it. The Cambridge Assessment Framework rigorously prioritizes analytical depth over superficial breadth. You have to demonstrate connected, conceptual understanding that you can transfer to completely unfamiliar contexts. When the examiner uses specific command words like show that, hence, or determine, they aren't just making polite conversation. They are triggering very specific assessment objectives. If you don't decode those command words, you're flying blind.
Which brings us to the million-dollar question. Why do students lose marks on Argand diagram loci despite actually knowing the math? Let's bring Alex and Sam back into the picture. Imagine their exam papers side by side. Alex knows every formula in the book. So Alex gets a loci question and just starts word-vomiting equations. There's no structure, no clear starting point, it's just raw data. Alex might get the final shape right, but the examiner gives it a 3 out of 10. Why? Because there's no logical pathway. Then look at Sam's paper. Sam is fast. Sam sees the equation, knows it's a perpendicular bisector, draws a line, and moves on to the next question. Sam ignored the command word hence, which means Sam was supposed to use the previous part of the question to inform the answer. Sam also didn't state the coordinates of the endpoints, so Sam's paper is covered in red ink too. They both knew the underlying math, but they completely failed to play the game the examiner designed.
It all comes down to this, the method mark strategy. Look, Cambridge examiners award marks for your process, not just absolute perfection at the finish line. This is where we introduce a game changer. We adapt the classic Peel framework, point, evidence, explanation, link, specifically for mathematics. Yes, Peel isn't just for essays, it's the secret to structured math answers. Your point is explicitly stating the geometric feature or locus type you've identified. Your evidence is the clear algebraic manipulation and the formulas you're applying. Your explanation is showing your step-by-step working out, proving how you found the center and radius or the gradient. And finally, the link. You link your geometric shape directly back to the specific constraints and inequalities given in the Argand diagram prompt. If you just guess the final locus or draw a rough sketch without mathematically justifying those Peel steps, you hemorrhage method marks. You have to prove your analytical depth at every single stage.
And here is a major secret, straight from the principal examiner reports. Listen to this closely. Candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of complex numbers doesn't exist in a vacuum. Whether you're working through foundational concepts in 0580, stepping up to 0606, or the 4000 series like 4024, 4037, and 4040, or dealing with the advanced 9709 material, the rule is the same. The math is interconnected. Loci and Argand diagrams rest on precise definitions, causal relationships, and integration with other syllabus areas like trigonometry and coordinate geometry. Top students treat mathematics as a fully integrated system. They don't just see a complex number. They see a vector, they see a trigonometric ratio, they see a coordinate geometry problem. They show the examiner exactly how the moving parts connect.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get right back into the core framework and see exactly how to apply this to transform those red marks into green checks.
Welcome to Section 2, the procedural framework. This is where we start the transformation. This is the step-by-step methodology, the absolute architecture that top candidates use to guarantee maximum marks on their papers. If Alex and Sam had used this, their papers wouldn't be covered in red pen, they'd be lit up with green check marks. We are going to build your mathematics success blueprint right here, right now.
Systematic processing within complex numbers loci follows a very standardized, very rigid sequence. You need to lock these 5 steps into your exam routine. Step 1. Identify key elements. You deconstruct the question, highlight the command words, and extract the relevant data. Step 2. Apply relevant principles. This is where you select the correct analytical framework. Are we dealing with a circle, a bisector, array? Step 3. Execute analysis. This is your evidence and explanation from the Peel framework. Clear working, perfect notation, no skipping steps. Step 4. Verify results. Does your locus actually satisfy the inequality? Did you check the boundaries? And step 5. Present format. Draw it clearly, label the axes, mark the key coordinates. This rigid 5-step process is literally what transforms Alex's chaotic working out and Sam's rushed sketching into a flawless, high-scoring response. It forces you to slow down and hit every single method mark along the way.
Now, I know under exam pressure, when the clock is ticking, it's really easy to freeze up. So here is a mnemonic hack directly inspired by the top scorers. Create a memory device using the first letters of those key framework terms, IAEVP. Identify, apply, execute, verify, present. IAEVP. Say it to yourself when you sit down for the paper. Practice applying IAEVP to a complex problem from a past paper, and you will find yourself systematically claiming every available method mark. You won't be guessing what to do next. The framework tells you exactly what the next step is.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's keep going.
Let's dive into Section 3, Top Examiner Warnings. We are shifting gears now into an interactive workshop mode. These are the classic mistakes pulled directly from the principal examiner reports. If you want to know what absolutely not to do when plotting loci and Argand diagrams, pay very close attention. In fact, let's test your skills right now with Challenge 1, the data scan. Imagine a complex data chart representing a locus problem is on the screen right now. I'm putting 60 seconds on the clock in my head. Your job is to extract the chord trend. What's the main constraint? If it says the argument is between 0 and pi over 4, what quadrant are we trapped in? You need to be able to scan and extract that critical data instantly before you even pick up your pen.
Now for Challenge 2, Find the Flaw. I'm going to walk you through the top 3 things examiners constantly flag, and I want you to think about which of these you are guilty of. First, students confuse cause and effect. They might see a strict inequality, like less than, instead of less than or equal to, and they draw a solid line instead of a dotted line on the boundary of their circular locus. That's a massive deduction. Second flaw, forgetting to check format and presentation. This means missing proper headings, lacking correct terminology, or failing to use clear annotation on the graphs. An Argand diagram without labeled real and imaginary axes is just a blank cross. It means nothing. And third, providing generic answers. They write down a memorized definition that has absolutely nothing to do with the specific numbers in the question.
This leads us to Challenge 3, Speed Writing. We've got 30 seconds on the clock. Think about how you would write a perfect Peel paragraph to explain a locus. The classic mistake, as we just mentioned, is writing generic, memorized answers. You might have memorized perfectly what a perpendicular bisector looks like when you see the modulus of z minus a equals the modulus of z minus b.
great. But if you just write it's a perpendicular bisector and don't adjust your answer for the specific complex numbers given in the scenario, you fail the link part of the Peel framework. The top strategy? Always link every single point, every annotation, every geometric boundary, and every algebraic step directly back to the specific context and data provided in the prompt. That is how you max out your score in 30 seconds of writing.
And this brings us to the final piece of the puzzle. Section 4, Critical Analysis Strategy. This is the complete mathematics answering system. This is where we talk about evaluative thinking. If you want to decode the matrix of the top grade bands, you have to execute comparative and critical analysis seamlessly. There are 3 rules that guarantee top marks here. Rule 1 is command word decoding, knowing exactly what the examiner wants. Rule 2 is flawless Peel framework application. And Rule 3 is the time management matrix, allocating your time based on the method marks available, not just rushing through like Sam or getting bogged down like Alex.
Let's break down how top-scoring candidates actually demonstrate this evaluative thinking. It happens in 3 distinct actions. First, they question assumptions. This action identifies limitations. For example, realizing that a half-line locus might only exist in a specific quadrant based on a principal argument constraint. You can't just assume the line goes on forever. Second, they consider perspectives, which finds alternative interpretations. Could this complex equation be solved more efficiently using Cartesian coordinates rather than polar form? And third, they justify with evidence. This solidifies conclusions. They support every comparative connective with rigorous algebraic proof. They evaluate the quality of their own evidence and prove to the examiner beyond a shadow of a doubt exactly why their locus is correct.
Look, the data absolutely does not lie. We've seen it time and time again. Students who implement these precise loci strategies, the ones who adopt the IAEVP framework, who use Peel to structure their math, and who actually heed the examiner warnings instead of ignoring them, they see an average improvement of 2 full grade boundaries. That's the difference between a C and an A. 2 whole grades. But let me be perfectly clear, that only happens if you practice consistently. You can't just watch this once and expect magic. You have to put the reps in.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
We have completely deconstructed the framework today. We've analyzed the real examiner reports, we've decoded the matrix of Argand diagrams, and we've built a system that works. You now understand the method mark strategy. You know how to avoid the traps that get Alex and Sam every time. Now that you can literally see the code behind the questions, how are you going to rewrite your exam reality? I challenge you right now to take the IAEVP steps, apply the Peel framework, and conquer the very next past paper you attempt. Go get those green check marks. Until next time, keep analyzing, keep verifying, and keep pushing your boundaries.